Thank you, Leon. Hello, everybody. I'm Bidusha, and today I'm here to present to you about the ECC VIAL. About 2 billion people in the world lack access to safe drinking water. And as many of you might remember from our presentation last year, we started the project with the vision to provide safe drinking water to all, starting with Nepal. And for that, we needed an easy, cheap, and reliable water testing solution. We worked on this project for about a year, and our solution is the ECC VIAL. It is a product that we have developed to test if the water sample has fecal contamination or not through the detection of E.coli and coliform. As you can see in the slide here, our product is really easy to use. The results are reliable, and it is one of the cheapest products for water testing that's available in the market today in Nepal. It costs about $1.37 per test. And if you look at it, if we really break it down, 70 cents is for the vial, which is one-time use, and another roughly 70 cents is for the pocket incubator, which can be reused. And we highly recommend people to test their water sample at least twice a year, once during the rainy season and once during the dry season. So ideally, the cost is about 70 cents a test. Our product is very portable. On the final packaging, after everything is done, it is about 9 centimeters by 3.5 centimeters. It also eliminates the need for a lab because we can test the water on the spot. And it produces visually interpretable results, so we don't really need expertise to analyze the results. So just to give you an idea about what components are there in the product, there are two basic components. The first is the vial itself, and it has a chemical infused paper inside it. The second is the incubator. We have 3 different types of incubators available. The pocket incubator and the body belt incubator, it uses human body heat for the purpose of incubation. Whereas the mini incubator that we call Mincubator, it uses electric power. Now let's look at how does our product work. First, we, as you can see in the images on the left-hand side here, we collect 10 milliliter sample of water in our vial. We then incubate it for about 24 hours using one of the available incubators. In the image here, we're showing the pocket incubator. And after incubating for 24 hours, a vivid color change, it indicates if the water sample is microbiologically contaminated. There are 4 possible color change outcomes. The first one is the sample of water, it does not change the color. And that indicates the absence of E. coli and coliform, and so the water is safe for drinking. The second case, the sample water might change blue, which indicates the presence of E. coli. Red indicates coliform, and both red as well as blue indicates the presence of both E. coli and coliform. And in the 3 cases of color change, we know that the water is unsafe for drinking. Now let's look at what have we accomplished so far. We partnered with an organization, a company in Nepal, and we manufactured 3,200 units and distributed 600 units, impacting 3,000 lives. The team at MIT, we also performed shelf life studies for our product. We also traveled to Nepal and we trained the local Nepalese on lean manufacturing procedure to really help them improve their manufacturing processes. We also successfully launched our product in Nepal in January 2020. And during the launch, we had former Minister of Environment and Science, as well as many other government employees in attendance. Following the successful launch of our product, we also identified the target market, and we have already started our communication with them. And to many of these distributors, we've also provided our sample kit so they can start testing water samples. As you can see on the table here on the right-hand side, Our target is to sell 40,000 vials by August 2020, and we believe it will impact 1 million lives in Nepal. We've also included the detailed calculation in the appendix side if you guys are interested. Now let's look at next steps. We're working to expand our efforts beyond Nepal, and we have identified India, Bangladesh, Sri Lanka, Thailand, Ghana, and Nigeria as our potential expansion countries. We're also working on the bidding process to submit ECC kits to UNICEF Supply Division. In parallel, we're working to secure product certification in Nepal and comply with all the regulations of other organizations like UN, UNICEF, WHO, and so on. Our team is really working on refining the standard operation practices. And what that means is we're looking at creating how to manufacturing manual, just in case we decide to manufacture the product in the countries that we've identified. We're also doing comparative studies between our product and other available products in the market to ensure that our product is best in class. Also, for the mini incubator or MINcubator, we're doing the temperature stability test for quality control. We're also thinking about ECC VIAL 2.0, and for that, we're specifically looking at two different things. The first, we're playing with different water sample volume just to see if we can detect E.coli at lower concentration. And the next thing is we're trying to explore if we can decrease the incubation period from 24 hours, maybe down to 6 or 10 or even 12 hours. Our big goal here is to sell 40,000 vials in Nepal by the end of August 2020, impacting about 1 million lives. We would then like to expand the numbers to 75,000 vials by the end of 2021, impacting about 3 million lives. In parallel, we hope to expand beyond Nepal and continue on our mission to provide safe drinking water for everyone. Thank you.